Alright, hello geometry people. Here is our test review. So I'm going to try to work through these problems as efficiently as I can. So if I'm going too quick, feel free to pause it. But I would highly suggest you work through this entire review first, and then check your answers with me. So first of all, before we start, I would go ahead and have you guys pull up this you can see this, the circulars formula sheet. I put it on Schoology. So I don't know if you can see a good angle of this, but okay. Anyways, just pull it up. It should be there with it in the same folder. So just make sure you have this handy, just so you're able to swiftly work through the problems. And so I'm also going to reference it throughout this review, so just kind of have it handy, if not pulled up on your computer or something like that while you're doing this. Okay, so the first question we're going to look at is it's asking for the length of each arc. So I'm going to look over here at my formula sheet, and the arc length formula, so I'm going to just call it AL, arc length, is my angle, which is theta times 2 pi r all over 360. Okay, and so this is like our lesson that we did last week. So I would just go ahead and have that formula ready. And then from there, it's just plugging it in. So arc length is equal to theta, which is my angle that I know, which is 135, times 2 times pi times my radius, which is 14, divided by 360. And I'm just going to put that whole thing in my calculator. And you can do this with me. Now I'm just going to use 3.14 for pi. Make sure when you put in your calculator you're not missing any of these things. Like all 4 of these are separate that you need to multiply together. And then I'm going to divide that by 360. A common mistake that I see is just people forgetting to like multiply the 14 or something like that. So you should get 32.97, which rounds up to 33. Okay. All right, so here's the next one. All right, same thing. I'm just gonna use the same formula. Arc length is equal to theta times 2 pi r all over 360. And you can just go straight to plugging it in if you got it. Okay, so then I'm just gonna plug it in. Okay, so you multiply all these together and divide by 360, and you should get 36.63. Okay, and because my calculator I'm using 3.14 instead of pi, it gave me 6.3, but none of these are anywhere close to 36 point something. So that's why C is the correct answer. So my rounding was a little off because pi wasn't used exactly. If you want, I would use the pi in your calculator already because it'll give you a more exact answer than 3.14 will. So I'm going to do that for this next one. Okay, so again, we're going to use our formula. Theta times 2 times pi times my radius, which is 13. And notice I'm just plugging it straight in. Oh wait, but I didn't plug in my angle. Okay, and I'm writing it backwards. All right. This may remind some of you guys of class, how I write things down sometimes wrong. Okay, there you go. 315 times 2 times pi times 13 divided by 360. So I kind of skipped a step. I didn't write out the formula. But we do 315 times 2 times pi times 13 and divide that by 360. Okay, so I got 71.47. Okay, so 71.5 would be rounded to the nearest tenth. Okay. Then it's asking just to find the area of each sector. So we're gonna look, if we're looking for the area, we're gonna use a different formula. The sector area, I'm just gonna do SA for short, is theta, which is my angle, times pi, times r squared, divided by 360. So the only thing is we're using the formula for area of a circle instead of the circumference. Okay? And so from there, we'll just plug everything in like we did before. 300 is the angle I'm using. Okay, and so I'm just gonna put this whole thing in my calculator. 300 times pi. And I put in parentheses, I put 12 in parentheses, or you can go ahead and just do 12 times 12 is 144. And then I'll divide that by 360. Okay, so when I put that in my calculator, I got 376.999999. So rounding to the nearest tenth, I'm just going to round up, so it'd be 377 miles squared. Alright, I'm going to just jump in. I'm just going to plug it straight in, so this would be 120 times pi times my r squared divided by 360, and I'll put that in my calculator for this next problem because it's very, very similar to the one we just did. So from here you should just be checking your answers with me. Almost forgot to divide by 360. Let's see. Okay, so I got 104.7 the fish. No, I'm just kidding. 104.72. So yeah, 104.7 the fish is the answer. There you go. All right, so then we'll move on to number 6 and 7. And again, I'm just gonna plug these straight in because we're just finding the area for each, so it's just plug and chug. So 150 times pi times my r squared divided by 360. Put that in your calculator. And you should have gotten 221.2, which is C. And then I'm going to do this next one. So a lot of these questions on this test, the 7 questions on your test, are just plugging in numbers and finding your area and your sector or and arc length. So these should be pretty easy. So for this first page, you should get 100%. Okay, so make Ms. Garner proud. Get that 100. Okay, so this is 188. Oh, you can't even see what I did. Sorry about that. Okay, so I just plugged in my angle, pi r squared divided by 360, and I got 188.49 or 0.5. So D is the correct answer. All right, next page. Okay, so these can look pretty intimidating, but they're actually stuff we've already learned this. So it looks a little weird because it's inside a circle, but if we just took this whole circle thing away, right, and just looked at this triangle, what do you notice? It's just a right triangle. Okay, so with that, we know this is labeled C, this is A, this is B, and all we're going to do is use our Pythagorean theorem. So A squared, 9.4 squared, plus, just a reminder, this is our Pythagorean theorem, And I will not give this to you on the test. Y'all should know this Pythagorean theorem by now. It's something we've used a lot. So just commit that to memory. 9.4 squared times 11.2 squared equals c squared. Okay, and I'm just going to put that in my calculator. Okay, and when I put that on my calculator, I get 213.8 is equal to c squared. And then we just take the square root. So, alright, so you should have got 14.6. So, B is your correct answer. Pretty easy. Okay, so this next one, though, is a little bit more work, but not really. We use one of our theorems for this one. Since we know this is our diameter and this is a perpendicular line, we know, right, that these two sides are equal. So if I know this is 16.3, I know that this is also 16.3. Okay? And then from there, it's just A, B, this is C. A squared plus B squared equals C squared. 5.9. It's so hard to get this little stand out of the way. 5.9 squared plus 16.3 squared equals c squared. And I'm going to put this into my calculator. Someone just came into the door. So let's see here. Then we got 16.3 squared. And this is 300.5 equals c squared. And then to find c, I'm take the square root of either side. Okay, and so that should equal, okay, that should equal 17.3, okay? So, x is equal to 17.3. Now this one, these last two are pretty tricky, but I'm hoping that when I explain it, you'll be like, oh, I get it. So I've been given that 31 is my full length of my diameter. So to find my radius, I would need to take half of 31. So to find the distance from here to here, I can take half of 31, which is 15.5. Okay. Now, if I know this is 15.5, I can also conclude that this part right here is 15.5. Okay, because it's also, a radius is just the distance from my center to the side of my circle. So, I can find, okay, so this whole thing is 15.5. I'm trying to show you how to mark it. Alright, so this is 15.5. Okay, so my question is, if I know this side is 15.5 and I know this is 12.8, can I find this? Yeah, I just use my Pythagorean theorem. So this is C, this is A or B, I'll just call it B. And then let's try to find A. Okay, so we're going to do A squared plus 12.8 squared equals 15.5 squared. Okay? Then we're going to solve for A. So I'm going to do 15.5 minus 12.8 squared. Okay, equals A squared is equal to 76.41. Okay, so then to find my A value, right, I'm just going to take the square root of that. Okay, and then I'm going to do, so I'll get 8.74. Okay, so now they know that this part is 8.74. Okay, I'm going to, hey guys, would y'all mind going somewhere else while I record this for my students? Thank you guys. Okay, so I know this is 8.74 and I know this whole length is 15.5. So I'm going to take 15.5 and I'm going to subtract it from 8.74. So 15.5 minus 8.74. So this is like 6.76. Okay, so this will round up to 6.8. And now, since we know this whole distance was 15.5, we know this part is 8.74. We can conclude that x is equal to 6.8. Okay, so that's a lot of steps, but this next problem is just like it. So we're gonna do that one real quick. So same thing. We know that my radius is, so this time we weren't given our diameter, we're just given the radius. So I can draw this radius anywhere I want. I could draw it here, 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 here. It doesn't really matter. Okay, but I want to try to make a right angle with this side that I know. So if I know this is 17.8, I also know this is 17.8. Okay, and then I can try to find what this length is, which will be we'll just call that one A, this is B, this is C. So A squared, oh, y'all need to be able to see this. A squared plus B squared, which is 15.1, equals 17.8 squared. Okay, and then A squared I know would equal, I'm going to go ahead and subtract these two and kind of do that part in my calculator. Okay, so I'll do 17.8 squared minus 15.1 squared, and then I get 88.83. And then I'll take the square root of either side, and so A is equal to 9.42. Okay, so I know this length right here is 9.82. Okay, and I know this is my radius because it's just a line from my center to the end of my circle. So I know I was already given my radius is 17.8. So I can take 17.8. So I know this whole distance is 17.8 minus from, oh, I realized I wrote this down wrong. It should be 4.2, not 8.2. Sorry, y'all. 4.2. So if I do 17.8 minus 9.42, I should get 8.38. Okay, and that rounds up to 8.4. Okay, so these two problems will probably be ones that y'all need to do a couple more practice problems on. So I will upload some practice problems that look like these last two for you guys to work through. I'll also put the answers with it so you can check yourself. And then these last two are really, really simple. Basically, because we know this is a tangent line, we know that it forms a right angle here. And also, on this next problem, there's a right angle that forms here as well. So it's the same thing. We're just using our Pythagorean theorem. So I would literally call this page of the test Pythagorean theorem page, okay? You're going to have to use Pythagorean theorem to find all of these. So this is A, B, C. So 15 squared plus 8 squared equals C squared. I'm going to put that on my calculator. And then take the square root of it. Okay, so I'll get 289 equals C squared, take the square root of either side. So 17 is equal to C. So the answer is 17. Okay, and then I'll do the exact same thing for this one over here. This is A, B, and my C is always across from my right angle. So 6.3 squared plus 8.4 squared equals C squared. And then I'll put that on my calculator. Okay, and so when I put that on a calculator, I got 110.25 equals c squared, and then I'll take the square root of either side, and that is 10.5 equals c. So 10.5 is d. So that's how you do that page. All right, we're on the second to last page. For this problem up here, okay, you may recognize this. This is one of the first things we did. We're going to use the formula, the chord and chord formula. So I'm going to try to put that in front of you real quick. So remember this formula right here, and we're going to use our tangent secant formulas. Okay. So for this first one, we use our chord and chord. So chord and chord says basically I can multiply these two pieces of the chord together, and then also instead of equal to these two chords multiply together. So I'll do 9 times x plus 9 equals 10 times x plus 7. Then I'm going to distribute. Oops, can't really see this very well. So this is 9x plus 81 equals 10x plus 70. And then I'm just going to subtract. Okay, these will cancel, these will cancel. So I'm left with 11 equals x. Okay, and so it just asks to solve for x. So we're gonna get 11, so D. Okay, so you saw it said to solve for x. We found x by setting those equal. So that's basically how we do it. Okay, so I'm gonna do one, I'm gonna skip 15 for right now and just do 16 as well because it's a very similar problem. But we'll do 5 times x plus 1 and then 4 times x plus 3. And that's how we'll solve this problem. And again, I'm giving y'all these formulas on the test. Okay, you just need to know when to use them. So it's 5x plus 5 is equal to 4x plus 12. Okay, and then this is 7. Okay. All right, then we're going to go over here to number 15. And so we're going to use this formula for this next one where you see a tangent and a secant. So this is taking our tangent and squaring it and setting it equal to the one that the secant on the outside and multiplying it by the whole secant. So tangent squared and then multiplying it by the whole secant and the part that's on the outside. So looking at this one, my tangent is what's kind of like hitting the edge of the circle. So we're going to square that one. So we do 15 squared, move this over a little bit, equals the one on the outside times the whole distance, which is 9 plus x. Okay, and again, I'm going to give you these formulas. You just need to know how to use them. So we're going to, distribute. We're going to multiply. 15 squared is 225. This is 81 plus 9x. Okay, then from there, we're going to subtract 81. Okay, and so that's equal to 144 equals 9x. I'm going to divide that by 9. And we get 16. Okay, so that's D. All right. Then let's go down to this last part. Okay, so Mr. Robinson taught you guys these. He's another geometry teacher at the school, and so we kind of split up some of the lessons. But one of the things you learned from him was that to find our center, basically you just take the opposite sign of what's inside of each of my parentheses. So whatever's with the x, that's going to be the x value of my center. Whatever's with the y is going to be the y value of my center. So, but the opposite. So the center, just looking at this, should be the opposite of positive 11, which is negative 11. And the y value of my center should be the opposite of 11, which is negative 11 as well. Then the radius, remember this part is equal to r squared. So I know r squared has got to equal 43, sorry. So to find just what r is, I can take the square root of 43, which is square root of 43. And notice these are still left in square root form, so it works out. So I want to try to find that answer somewhere, and it just so happens it's the first one. So A is the correct answer. All right, we'll go over here to 18. Same thing, right? To find the center, I'm going to take the opposite of what's inside with my x. So it's a negative 7. It's going to be a positive 7. This is a positive 1 for my y. It's going to be negative 1. Okay, so it's the center I'm looking for. And then, again, my radius, this part is r squared. So 121 is equal to r squared. I can take the square root. I know that 121 is a perfect square. So that's going to equal 11. And notice all my answers had 11 in it. So I'm pretty, oh, actually not this one. So cross that one out. But most of the answers had 11. So it's a good indicator that it's probably going to be 11. But the only one that has a center of 7, negative 1 is D. So be careful because B looked very similar. They just didn't switch the signs. So make sure you switch the signs. All right. That's the last one. Last two, I should say. Okay. So this time we're looking for the actual drawing of the circle or the sketch of the circle. But we're going to do the exact same thing. We're going to find the center first. The center, just looking at this problem, would be positive 1, positive 1. And then my radius, which is r squared, is equal to 16, so r is equal to 4. So notice all of my answers had a radius of 4 in them. And then, but honestly, I don't even have to look at the graphs. Let me see if I can. I don't even have to really look at the graphs because all of my centers are different. It's really hard for me to show you this right now. Okay, so like see for this first one, it is negative 1, 0. Okay, that one's not it. This one's negative 1, negative 1. That's not it. 1, 0, not it. Last one, 1, 1. Okay, that's the one we're looking for. So with these last two questions, you honestly can just use the same logic as you did for the last problem to answer them. Okay, we'll do the same thing. Center is negative 2. Oops, I can't see this. Opposite of 1 here, which is negative 2. Opposite of this, which is negative 3. R squared is equal to 9, so R is equal to 3. Okay, and so there's only two answers that involve the radius being 3, so I can go ahead and cancel A and C out. Okay, I don't know if y'all could see that, but A and C are the two ones with a radius of 2. We're looking for a radius of 3. And then B has a negative 2, positive 3, which is not right. Okay, so D is the only one that will work. Okay, so that is your test review. If you have any questions, feel free to ask me. Or if I went too fast, feel free to rewind it. Again, I want to put some extra practice problems for those two for you guys along with the answers. So if y'all need any extra help, you can look there. All right, see you guys. Good luck on your test. Hope you get 100. Bye.